Thank you for joining our presentation, Striking a Balance, How True Partnerships Decrease Costs and Lead Times. Our speakers today are Dax Strohmeyer, CEO of Triangle, and Ken Gredick, Triangle's Director of Engineering. Triangle is a leading contract manufacturer of high-performance precision CNC machined implants, devices, and instrumentation for the orthopedic industry. Family-owned since 1955 and based in northern New Jersey, Triangle partners with the world's leading OEMs to get from concept to market using its expertise in design for manufacturing, design for inspection, and lean manufacturing principles.
Hi, and welcome to OMTech. My name is Dax Strohmeyer. I'm the CEO of Triangle Manufacturing in New Jersey. And today I have with me Ken Gredick, our Director of Engineering. Ken and I are going to talk a little bit today about some of the differentiators that Triangle brings to the table, specifically two: design for manufacturability and design for inspection. We believe that these are two areas that we can affect not only change to the fit, form, and function of the devices that we're making, but also ways that we can improve lead time and, more importantly, cost. So, Ken, welcome.
Thank you. Thank you. I'm excited to be here. Thanks for having me.
Yeah. So I'm looking forward to our conversation. So tell me a little bit about DFM and DFI here at Triangle and how that affects our product realization process.
Of course. Well, as you said, it starts with our product realization process, which is really the process for creating our manufacturing process. And the way DFM and DFI really fit into that is upfront, if we're involved with the customers where the design isn't solidified, we could really give some improvements to their design for our manufacturing purposes, the quality of the parts, and ultimately come up with a better design for the customer and make it more manufacturable.
Well, that sounds great. I'm sure that a lot of our customers and valued clients out there have taken advantage through the years of getting involved up front, getting us involved up front, where we can really have a real impact. You know, a lot of the times when you're dealing with legacy products that the designs have already been locked down and are already into supply chain, it becomes difficult to make some of these changes. So, you know, we really like to get focused on that early on piece of this, right?
Agreed. In fact, I have two examples here. And on this slide, I've got a little widget that I'd like to talk about. There's two potential improvements that I could make on this widget. And if you look at it, it looks like a simple part. The way that we would process this part is we would turn the OD, pop a hole in the ID, mill out a 1-inch square, and then we would send it out for heat treat. And when we get it back from heat treat, we would grind the OD and wire the internal square. Now, that seems like a lot for this little widget, but with all the features that are required on this print, unfortunately, that's the way that it has to be made for us at Triangle. Now, there's two features on here that we really want to dive deep on to really look at potential savings for the customer. There's actually a lot on this, but I'm going to focus on two. On the top left, there's a 4 times radius of 0.005 max. And for us to generate that, we would have to use a 6,000ths wire in the wire EDM. And it would take about an hour and a half to make, which is a long time considering what this product really is and what it looks like. So if we were to get our customer involved up front, and we're to take a look at the assembly, we could recommend putting a chamfer of 1,000th more on the part that goes in there and change that radius of 5 max to 6 max. And what that will do for us, Dax, is that'll allow us to move from 6,000ths wire to 10,000ths wire. And really, ultimately, that's going from an hour and a half process down to an hour process. Quite a big savings in time for us.
Absolutely. And going through that process, most of the other steps in the process are somewhat insignificant relative to the EDM step. So the time that you mentioned before, an hour and a half, saving a whole half an hour, that's a third of the cost of the most expensive step in the process. And that, for a very minor change, that's a real cost savings that our customers can realize.
Yes, absolutely. Another one, it's more of a manufacturing issue. If you look on the right-hand side of this part, it says R.063. Now, to generate that feature, it's about an inch deep in there. And there's a principle that we use. It's the L over D, or length over diameter principle. To make that feature, we're going to use an end mill that's about 125 in diameter. So that 125 diameter could go 3 times deep using that 3-to-1 ratio on there, which is a depth of 375. If you start exceeding that 375 depth, you're going to start getting chatter. You're going to potentially not even be able to hit the customer's print tolerance on there because it's sticking so far out. It's actually bending as it's cutting out there. So it really could be a significant issue when it comes to manufacturing. What we would do is we would recommend one of 2 things to the customer at this point. The easiest would be to take the depth of that cut and change it from 1 inch down to 375, and then we don't have to change anything, and life is good. If they need that 1 inch deep depth of that cut, we would request that radius get changed to 172. And if we do that, we could use an 11/32 end mill and reach that 1 inch depth. So really, this is more about our process and the way it's manufactured and optimizing it so that we could make a quality part.
Absolutely. And also achieve a better surface finish. If you avoid that chatter, if you have a mating component, you really can have a better fit and function. So all the way around, just some minor tweaks and changes to the design of the component can really affect the manufacturing process in a way that not only saves costs, but also can potentially improve the actual component itself.
Yes, absolutely. Yeah.
So how about DFI? How does that impact some of the things that we've been talking about today?
Well, I do have another slide up here for DFI, but before we get to that, I want to talk about the 6 degrees of freedom. So on a print, we 3D printed this little object here to talk about the 6 degrees of freedom, which is you have your up, down, your forward, back, your right and left. Those are basically the location of that center point. And then you have the rotational, which is your pitch, your yaw, and your roll on here. So it's important to make sure that when you're defining a print, that you have these 6 degrees of freedom really tied down. So that way, when you're inspecting something, that you're inspecting it based off of a defined reference frame. So on this print that I have up here, we have an example highlighted here. It's a 3.53 radius plus or minus 10. And I have a part here as an example. So that 3.53 radius is about in between my thumbs here. And it's a very small part of an arc here. But if you're looking at it straight on, say you're measuring it on a comparator, and they're looking on it straight on like this, and it's measuring 3.53 exactly. Now, if you start introducing some roll in there, and you're looking at it like it starts getting perplexed, and that 3.53 is not going to be measuring 3.53 anymore, which is going to stop the production from going because there's an issue. So that's one thing that I'd like to point out. The other thing on this is sticking with that 3.53 plus or minus 10, that feature, again, in between my thumbs, it's about 10 degrees of an arc. So if you're to draw a circle all the way around here, 360 degrees, it's only about 10 degrees of that arc. Now, the design intent for that feature is you have plus or minus 10 on the radius, so that's a 20,000th band. So you have a 20,000th band for that radius that the designer has intended for that product to meet. Because this is such a short radius, you could have projection error, which would really throw off the feature itself. As an example, what I did is I threw up in CAD, if you had 3.53 point here, and you took the point in the center and you moved it up only by 0.5 of an inch, your arc, the resultant arc on that is going to be about a 1/4 inch different. Now, that's only 0.5 of an inch different in form on that arc, but because it's such a short portion of an angle, that 10 degrees, it's projecting that radius out of tolerance. And again, it's going to stop production and you're going to have issues on the shop floor. So to mitigate that, what we would recommend doing is not only for that little arc right here, but really for this whole surface, is to change that into a profile. And to do that, we would need a good datum reference frame. And if this whole thing was a profile of 20 thousandths, we could just take a CMM probe, go across the whole entire area, and it'll tell us with confidence where we are within that plus or minus 10 on this part.
So you just spit out a whole lot of technical jargon, right? And for somebody who maybe isn't quite as technical like me, what that translates to, and what I think we have all experienced over the years, is false rejections. And this is something that if we take something that is as technical as you just described, and we're able to have these conversations up front with our clients, and we get inspection correlation, and we know that we're going to be using the same techniques, and that we're going to be approaching these inspections the same way, then we avoid the false rejections that we get, or that we can get. And we avoid all the back and forth and engineers meeting and talking and quality engineers getting involved. And it's just a smoother process. And I think that that's one of the most important things for me, listening to what you just described for design for inspection, is that we really need to understand how not only are we going to be inspecting the parts, but correlate how our customers are going to be inspecting the parts as well.
Yep, I agree 100%. And on top of the correlation there, the other issues that come up if it's not defined properly is if there's an inspector inspecting it per the print and they find something that's out, they're going to stop the production floor. And that's going to have a big bubble effect when it comes to deliveries as well.
Deliveries, cost drivers, all the above. Yeah, yep. Those are all things that we're trying to streamline and make sure that we eliminate as much out of the process as we possibly can.
Yeah, so a couple of simple conversations up front, tweaks to the print, it really could optimize the outcome.
Wow. Well, that's great, Ken. Thank you so much. I really appreciate you spending some time with me this morning and explaining DFM and DFI to our valued customers and the OMTech audience. So I really appreciate it. Thanks.
All right. Thanks for having me.
Thank you to Dax and Ken for sharing their insight, and thank you to those watching. To learn more about Triangle, visit their website at trianglemfg.com. You can also access more insight from orthopedic suppliers and OEMs at omtechexpo.com.